Okay, so today's project, this is actually some stuff from my work at the bowling center. I'm just taking it home because I'm better equipped here than I am there. We have these tracks, and I'm hoping you can see the teeth on here. But there's a large gear that runs around here, and it's got a pinch wheel on the other side, so it kind of squeezes this and it runs around this, and it's what we call a distributor on the Pinsetter. These are older 8230s. Some of the newer machines, they do it differently, but this is what we have, well, unfortunately these are made out of cast iron, which it's rigid, but they crack really easy. So I've got one of these, I believe, had a crack in it. The other thing that happens is when the distributor, it has like a latch and it stops for each position where it drops the pin, and that stop, particularly on this corner, can be a little harsh, and eventually it wears these teeth out. So this is mainly what I'm going to be looking at doing today. Is there's about 3 or 4 teeth right in this section here that need to be built up again. So I'm going to take just the tooth part of this, and then I'll be later taking it to the mill and I'll regrind the hollow sections of the teeth to reshape them. And that should get these back in good shape. that'll give me enough to work with on that one. By the way, I'm using stainless on this. I really should be using a nickel rod, but at $100 a pound, it's over what we can do, and stainless does typically have some nickel in it, and I've had good results with this. I've done a few of these in the past. I'm not a great TIG welder, but I find using the stainless on cast actually works quite well. It holds good, it machines well after, and I don't have any problems with it cracking after, so works for me anyways. So this is the track that I did the welding on the teeth. So this is what we got. Hopefully you can see that good. So they're built up from where they were worn. And now they stick up a little too far comparatively to the other teeth. So I'm going to take a grinder and we'll just take the very tops of these off so that the highest points are even with the rest of the teeth here. And then we'll be taking this over to the mill and we'll be milling out the space between the teeth to get the proper form in there. So I don't know if you guys have seen me use this before. I forget if I've shown it, but this is my air-powered angle grinder. It's I made this like 20 years ago. I mean, not much to it. What this is it's a buffing. It was one of the oscillating buffers. They get like a little bearing in there that's offset, and it just makes it vibrate around, or you can lock it and it'll do a rotary. So I took all that assembly off and I just made a custom hub on here that takes one of the larger grinding wheels, and I love this thing. It works great. Nice thing about it is that you can actually have a throttle on it. It's not just on and off. You can change the speed of it. I gotta get a look. They lean in a little bit, so I gotta get that angle on there now. Okay, so now I got to get this set up on the mill. It's a small plate on the mill, so this is a little tricky. I'm going to have a lot of overhang, and I'm going to be near the end. And this is uneven on the bottom. I think what I'm going to do, I got a pair of 1, 2, 3 blocks. I'm going to set it up on top of them to raise it on areas that I know are the same height, so we can get it level to the plate. And I'm going to be about at the end of my limit for the current layout. But one thing I can do with this, where this is made out of a drill press, is I can take this under table and I can swing it to the side, and that'll let me get the quill further over this way in relation to the table. So that'll let me get over here with a little bit more ease. Okay, so that's the end of the range for my table, and I'm going to see if we can rotate this. Okay, so I think that'll give me enough working room. Actually, I probably should raise this up too. Okay, so I think we're pretty well set up. I got a line up here, and we'll start on the first tooth. Tricky part, because I'm really just eyeballing this, is finding the right spot where I'm going to dive in here. Because the welds, you know, it's not a perfect thing when you've got the weld on there, so it's, you know, doesn't show you exactly where it's going to be. So I can really get a judge from the others. I may start on this back one, just so I can get a better idea of the spacing. A little on the top I can see, so that's kind of a help. Alright. I might be able to just do a plunge cut. Yeah, let's see how this goes. Okay, and I'm going to set it back down there, and I'm going to pull straight out, and I think that'll do it pretty good. I did overshoot a little on the depth where I'm doing this by hand, but that won't be a problem. Okay, so that's the first one. So once I got part way down, I decided to use my fine adjustment so I don't overshoot like I did on the other one. I didn't go too far. It was like half a millimeter, not even. It was like 0.4 millimeter, I think is what I read. But still, I'd rather have the fine adjustment when I get down there. So that's the second one, and we'll move on to the third here. Now once I get these cut, I'll show a close up in here. They always shift just a tiny bit when you tighten up the gids on it. at least on this. So I do a little fine adjustment once I get them mostly tightened in. I'll tweak it the last bit and then finally tighten it all the way. I think that's going to do it right there. No, got one more to do. This one may be a little trickier for me to get out of because I'm starting to get an angle on this one. If you haven't figured it out, that's the DRO up there. So I've got my readouts on there. In fact, you haven't seen this from the former videos. I think you can see that in there. So I've got my x-axis, which would be the longitudinal on the table, the y, which would be the shorter axis going in towards the back of the mill, and then the z-axis is how far down I bring the quill. Now on a knee mill or something like that, I think a lot of times they put the z on the knee instead of the quill, but on this where I can't do it's not really a knee, it's just a table that goes up and down, but it will shift side to side as well. So I never loosen that when I'm actually in the process of doing a mill with measurements. I'll get in a position before I start, and everything from there on I do with the quill with this particular machine. When you have something like a Bridgeport, the knee is very stable and you can use it just like an X and Y axis on this. So you can use that vertical movement for your milling as in addition to the quill. So it makes sense to put the DRO scale on the Z on there. pretty close here. Should be good enough to do the job. When I first started, I repositioned a little because I could see that I was cutting just a little too deep when I first started in. So I pulled it back about 0.4 millimeter. This tooth is maybe just a hair wider, but I think it's within the tolerance of what the head will take. I'll be checking that in just a minute. Let me get you a close-up in here. I'm just going to dust it off first. So this piece here is the head that rides on it. This is just a test one that I keep around the shop here for when I have to do these. This one it's broken, it's no longer good for service. There's an arm that comes down here and it's snapped off, so this is just scrap. But still has a functioning pinch wheel and gear that follows this, so it works for me to test this and make sure that the teeth are good enough for this to go around, which that right there feels really good. I'm not feeling any hanging as I go around the corner, so I'd say that's working. So that's what this track does. This is the head to the distributor on the Pinsetter. Pins come down a conveyor belt on this side. There's a belt that rolls over this, and the lever hits a latch on the front of this, which most of that is missing at this point. And each time it advances, it follows this track. That's just the pinch wheel on the back, if you can see that. And it'll follow around the track, and it'll stop for all the 10 different positions of where it has to drop the pins into the table on the Pinsetter. But I'd say that completes this project. This track is all done. So this one's a little different than what I was thinking before, and it's probably going to be a little challenging. Hopefully I can get this. But this section, it was ground. It was done before, and it was ground a little bit too thin. So when the pinch wheel comes along, it kind of hits a couple of bumps here, and it gets too tight, and will jam up the distributor going around. So I need to do a fill or resurface on here, where I'm going to put a fill layer on top and then regrind it flat. Well, it's not actually flat because there's a bend right here, but it's flat as far as that it's the same thickness as you go around here. I haven't done layering with TIG to try and surface the whole thing, so this is definitely going to be new to me, but I'm going to try it, see what I can do. The good thing is, where it's relatively flat, I've got good access to it, so I probably won't be struggling quite as bad with confined space and trying to get the right angle on the torch. Well, it actually went a lot easier than I expected. So I think I'm pretty close. I'll give a little more at the top here, but that's basically about what I'm looking for right there. Got one little spot right there. I think I want to add just a little. I'll probably also replace this spar, but I gotta find a suitable piece, and I don't have anything right handy right now. But that's gonna be in the works there. I'll weld in a little piece. But I think this came out pretty good. Just got to grind it down now, and that should take care of that. And I checked the corner teeth down here, and this one was already done not too long ago, so that's all good. And I need to work on my TIG skills. They're not the greatest, but I'm really happy with this torch. Stays nice and cool. Haven't had any signs of trouble with the internals getting hot. By the way, I should mention this is one of the CK Worldwides that I recently purchased. And I believe, let's see, this is the number 20, I believe. Yeah, CK20. And from what I understand, these are really good torches. But also, the water cooler that I built in the previous video seems to be doing its job quite well. In fact, I'm just going to see if I can get an idea of the temperature here. And I'm just putting my hand on the return fittings for the coolant, and they are nice and cool. Not even a hint of heat in there. So definitely doing the job. So this is just a quick view of the final version of the metal Z-wheel I made. I previously showed a plastic version in a former video. And here's with the spindle lowered, so you can see the retaining groove where the set screw goes in, and how it can go up and down freely, even with this end. There's a nylon washer at the bottom, which helps it spin freely at the bottom. And this is how the set screw goes in. And that just locks it so it doesn't drift while you're working on something that vibrates a lot. It just holds it in place. If you've made it this far, I hope you've enjoyed watching this video and found it entertaining or educational. If so, please consider hitting like or subscribe. It does help give me incentive to continue producing more. Thank you.